Hello, my name is Evolone Layne, and I'll be presenting Replicating Bugs Faster, which is the project I worked on with RIS this summer. So again, my name is Evolone Layne. I attend Howard University. I am currently a computer science major, and I graduate in May 2024. I'm very interested in machine learning and AI, and aside from STEM, I like to sing, dance, do music theory, and play piano. Robo Tutor is one of five $1 million finalists in the $15 million Global Learning X Prize. So, X Prize is a challenge where teams develop software. They give children the ability to teach themselves basic reading, writing, and arithmetic between a 15-month period. So, this is an Android tablet application built to teach children in Tanzanian villages with little to no access to schools, basic Swahili literacy, and numeracy. It combines decades of research on the science of learning with advanced language technologies and innovative machine learning tools for data-driven iterative design of educational software to increase the learning gains. So I also included the logo right there too. Okay, what is a bug? So a bug is a coding error in a computer program. So for this project, we classified bugs under stuck and crash. So a stuck bug is when the user is going through an activity and the application just it continues to run, but that activity gets stuck. Now, the only thing the user can do to actually get out of this is the back button, and now you're out of the activity and it couldn't be completed, which is very harmful to their learning. So, this is something that we need to fix. In addition to this, there are crash bugs. So, the crash bug crashes the application. So, the user performs a certain set of actions and the application just closes down. And in order to play the activity or go on to RoboTutor, you have to relaunch the app. So these are very, very, very crucial because now this is a self-taught application, and if the user at such a young age is not able to continue through the motion of the application, it hinders their learning. So our goal is to find a way to fix this. Okay, so the problem now is that it is difficult to replicate bugs without any type of documentation because as of right now, programmers just go through the motions of the application and hope they find a bug, and when they find the bug, they have to hope they remember the steps, which isn't very useful. So we propose a solution to ultimately help with this. The solution to this problem is a bug recipe, which contains a screen recording of the visible behavior leading up to the bug, along with a timestamp and other features that help developers diagnose bugs and debug their application. So I will evaluate my approach by the number of bugs I replicate based on the logs. In addition, I will look at the amount of time it took to apply this approach. If the time frame is shorter than that of the pre-existing debugging process, this method to generate bugs will prove to be more effective than the methods currently used by programmers. So I've also included the debug.json file we use. So this opens up the application exactly where the bug was tracked. So this is what we use when we are wanting to open the application, and I chose Story 65 mainly because on the pivot table that we use in Excel, this tends to show more problems. Every time this was ran, this produced a stuck bug, so it seemed like the best example to show you today. This research is very important because it is a blueprint for other programmers. So for the sake of the RISC program, we've used this to actually go through RoboTutor and find bugs, but this can benefit other applications outside of RoboTutor. So people that are now debugging applications and going through this manually and having to catch deadlines through a manual approach, it is hard for them to continue doing that. So if this method proves to be useful, it will really help everyone else in the computer science realm. So I think this research is very important for the advancement of the debugging process. So, thank you.